Vanakkam. Welcome to this course on biomedical instrumentation. We have been looking at temperature measurement since the last video. In this video, we look at the ways to measure body temperature, thermometers, specifically thermocouples, and what are the thermoelectric laws that govern the function of thermocouples. High school physics, time for you to revise. A clinical thermometer is a typical thermometer that you find in a primary care setting. Is a thermometer that is used to measure human body temperature. Usually it is put inside a mouth, sometimes in the armpit, for example. The old ones use mercury thermometer. So nowadays no one uses this. I already mentioned this. By the way, the mercury thermometer is an accurate and sensitive device because it has a relatively narrow bore through which mercury level rises, and the graduations are relatively accurate and sensitive. And usually the graduations are there in both degree Celsius and degree Fahrenheit. So both scales are available, and the scale usually is from about 34-35 degrees Celsius to about 42 degrees Celsius. That's the thing. Nowadays not being used because of the possibility of mercury poisoning. If this glass breaks, then mercury will spill, and it is extraordinarily difficult to clean up after mercury, which is why mercury, being the toxic chemical that it is, better to avoid these kind of things. And there are these 200 rupee digital thermometers that are available. In one of the previous videos, I actually asked you to check for what is the method that is used to measure temperature in a digital thermometer. Did anybody bother to check? Do check what is the method that is used. What is a thermocouple? If you join two dissimilar metal wires and create a closed loop with two junctions. Let us look at one wire like this that is made of a particular metal, another wire that is made of a different metal in a different color. So, there is a junction here and then there is another junction there, for example. Right. These are two dissimilar metals and there are two junctions. Now, if these two junctions are maintained at different temperatures, then a thermo EMF, what is EMF? EMF means electromotive force. A thermo electromotive force or a voltage develops, and because of the presence of this voltage, current is present, a current runs through this circuit. What is this effect? What is this principle called as? This principle is of course called as Seebeck effect. Not mentioned in the video, not mentioned in the slides. Do check this Seebeck effect. What is the difference between Seebeck effect, Peltier effect, Thomson effect? You need to know. So this voltage that is developed is actually quite small. What is the value? If the temperature difference is say 1 degree Celsius, you are going to have a change in the voltage of approximately 1 microvolts. Really small. So that means that this temperature difference will then have to be amplified. Now, another different but not unrelated thermoelectric law is the Peltier effect. This describes the situation when a current passes through a junction of two dissimilar metals, heat is either absorbed or released at a junction. So, the heat transfer and the voltage difference and the resulting potential difference is directly proportional to the temperature difference between the two junctions. So, if you pass a current, then two junctions have two different temperatures. This is the Peltier effect. Thomson effect, slightly different. In this case, within a single metal that carries current, regions that are at different temperatures either absorb or emit heat along the length. So, when you have a single metal, if you say one part of this cable is at a particular temperature, another part of the cable is at a different temperature in the same metal, Now, either it absorbs or emit heat continuously along the length of that cable. The EMF generated by this effect essentially depends entirely on the difference between the squares of the temperature, essentially difference between the temperature, difference between the squares of the temperature at the two ends of the conductor, of the conducting cable, for example. So, the net output voltage of a thermocouple essentially is due to the Peltier voltage at each metal-metal junction, at the two junction. What is this driven by? This is essentially due to the junction temperature difference. But then there is also the Thomson effect that comes into the picture, because the two cables may have different temperatures at different regions of this driven. This is due to temperature gradient along one of those cables alone. So, the net voltage is the output of is the sum of these two. These effects together essentially allow thermocouples to produce a potential difference voltage that is entirely dependent on temperature, and that you can calibrate, that you can linearize, that you can calibrate and use to measure temperature with a relatively high accuracy, reasonable accuracy and relatively high speed, very quick. So, here is a typical plot of temperatures and potentials that is generated. Note that these are not really the physiological temperature ranges, no, these are different. This is for industrial applications. Suppose you measure the temperature in a furnace, for example. How do you do that? For those kind of applications. So, definitely the temperature is of the order of 2500 degrees Celsius, but I am interested in a very small range between, say, for example, 33 degrees Celsius, or say 30 degrees Celsius to 45 degrees Celsius. This is my interest, or between 35 and 42, for example, is my interest. What you see is that, but still this principle applies. What you see is that different metal combinations have different slope of each curve is different, right? So, that is critical, and none of these is perfectly linear, there is non-linearity. So, that means that you will have to linearize within a range. So, each type of thermocouple, it's a combination of two metals, has a unique and specific non-linear response to temperature change. And so, that means that I will have to linearize this in the range of interest, because most of the recordings of interest are linear. The good thing is that the sensitivity does not depend on the size of the junction, because contact potentials are essentially related to the work functions of the metals. So, that means that the thermocouples can also be relatively small, really small. So, suitable for biomedical applications. Right. So, the net voltage that you measure, the net potential that you measure is essentially the algebraic sum of the various thermoelectric EMFs that are generated. What are these? Peltier voltages and Thomson voltages in any given circuit containing any number of, it need not be just two dissimilar metals, it can have more than two dissimilar homogeneous metals. It is a function of only the temperature differences of the junctions. If all but one of the junction is maintained at some reference temperature, which you need to know, then the EMF generated depends entirely on the temperature of that junction and can be used as a measure of temperature. So, the change from that reference can be used as a measure of temperature. This is used for sub-tissue level and in some cases even sub-cellular level transient changes in temperature, and for measuring temperature from within the body, for example, esophagus, rectum, etc. And can be inserted into catheters, can be really small that they can be inserted into catheters and hypodermic needles. So, as an injection also it can be inserted using this. And nowadays special needles are available that enable a thermocouple to be embedded subcutaneously for long term monitoring, relatively longer term monitoring, and after inserting it, then the needle can be withdrawn to leave the thermocouple in place. Note that this is a painful procedure, but maybe there is a clinical need to do that, and there is a clinical need to do that in some cases. and thin film thermocouples that are made of copper and nickel are useful in measurement of dynamic as well as static temperature measurement in biological tissue. So, they can be really small. Thin film means sub mm, sometimes thickness of microns. So, small sizes are possible with the thermocouples, essentially making sure that we can measure in various tissues. We already discussed within various organs like esophagus and rectum, can also measure the temperature profiles of the retina of the eye. Right. There are specific diseases that can be monitored by measuring temperature profiles. By the way, temperature of specific tissues within the body may be different from temperature of the neighboring tissues, and that may be an indication of health or disease. That is also frequently used as a measure of health or disease. Right. With this, we come to the end of this video. In this video, we looked at how to measure body temperature. We looked at thermometer, the typical mercury thermometer, digital thermometer, and thermocouples, and what are the thermoelectric laws and the principles that govern the flow of electricity across metals, dissimilar metals that are maintained at different temperatures. What are the laws? Seebeck effect, Peltier effect, and Thomson effect. What are these? And please revise these for your own understanding. With this, we end this video. Thank you very much for your attention.